I hope you're all doing well and are excited for today's session. It's always a pleasure to connect with you all as we explore another essential aspect of software engineering. Today, we're going to focus on a critical topic that forms the backbone of any successful software development project: process and control specifications. These specifications are pivotal in guiding software developers, ensuring they have a clear understanding of both the requirements and the objectives for a project. By establishing a structured process, we create a roadmap that enables developers to efficiently navigate their tasks, prioritize goals, and adhere to best practices throughout the project's lifecycle. Furthermore, well-defined process and control specifications help align the development team with the company's vision, making sure that the final product meets the needs and expectations of all stakeholders involved. As we explore these concepts, I encourage you to think about how these principles apply to real-world scenarios and the benefits they bring to the software development process. Today, let's explore process specification in software engineering, which plays a critical role in guiding the development and maintenance of software systems. In simple terms, process specification is about detailing the entire process involved in developing a particular software or system. It provides comprehensive documentation on how the software should be created, breaking down the steps, tasks, and methodologies required throughout the development lifecycle. Additionally, it includes instructions for maintaining the software after it's been completed, and addresses how bugs should be reported and handled. Now, let's understand how the process typically works. It all starts with the testers, who are responsible for identifying various bugs or issues within the system. Once these bugs are detected, they are reported to the manager. The manager then assigns a development team to investigate and fix the issues. To illustrate this, let's consider an example. Imagine Rakesh, who works in a small software development team building a mobile app. One day, a user reports a bug where they are unable to submit a form in the app. To fix this bug using the process specification method, we can follow these steps. Step 1. Identify the bug. The testers begin by identifying the details of the bug. They carefully review how the issue occurs and document its specifics. Step 2. Log the bug. Once identified, the bug is logged. This means acknowledging the existence of the bug and setting the stage for the team to resolve it. Step 3. Assign priority for the bug. Next, the testers assign a priority to the bug. Critical bugs that impact system functionality are given higher priority, while less severe bugs are handled afterward. Step 4. Fixing the bug. The development team now works on fixing the bug. This involves analyzing the issue and implementing a solution. Step 5. Verifying the fix. Once the bug is fixed, the developers verify the solution to ensure that the bug has been completely resolved and the software is functioning as expected. Step 6. Updating the status of the bug. Finally, the status of the bug is updated to reflect that it has been fixed. This update informs the manager and the team that the issue has been successfully resolved. By following this structured approach outlined in the process specification, teams ensure that bugs are addressed in an organized and efficient manner, leading to smoother development and maintenance of the software. Thank you for your attention, and let's move on to the next topic. Let's now talk about control specification in software engineering, which is a vital aspect of managing and maintaining the control over the software throughout its life cycle. In simple terms, control specification is all about establishing a clear set of rules and processes that define how control will be maintained within the software system. It's essentially a framework that ensures the system behaves as intended and allows us to manage its operations effectively. By defining the control specification, we gain a deeper understanding of how the system functions, making it easier to monitor, manage, and troubleshoot. This clarity also aids in performance optimization, ensuring that the system runs efficiently, meeting performance goals and responding well to various conditions. Now, let's dive into the components of control specification in software engineering. To have a solid understanding of how control specifications work, it's essential to familiarize ourselves with the key components involved. These components help ensure the software system remains efficient, secure, and reliable. Let's look at them one by one. Concurrency control. Concurrency is crucial in software development, especially in systems that handle multiple tasks simultaneously. Concurrency control refers to a set of mechanisms that manage shared resources across tasks, ensuring that data remains consistent and synchronized. In simpler terms, it ensures that multiple tasks or users can interact with the system without causing data conflicts or inconsistencies. Authorization and access control. Authorization and access control are essential for managing user access within the software system. They define the rules and permissions that allow users to log in or access certain pages or functions based on their credentials. This helps protect sensitive data and prevents unauthorized access to parts of the system that should remain secure. Error handling. Every software system is likely to encounter errors at some point, whether it's from a user input, a system failure, or an unexpected situation. Error handling is a crucial component of control specification, as it defines the procedures the system will follow when an error occurs. This ensures that the system can either recover from the error or provide helpful feedback to the user. Input validation. Input validation ensures that the data entered into the system is correct and meets predefined criteria. For example, when creating a username or password, certain rules must be followed, like not allowing special characters in the username. Input validation is used to filter out incorrect or malicious data, ensuring that only valid information enters the system. So, to summarize, these four components, concurrency control, authorization, access control, error handling, and input validation, are key to maintaining control and ensuring the smooth functioning of a software system. Now, let's explore the advantages of process and control specification in software engineering. These specifications play a crucial role in ensuring that software development projects are completed efficiently and with high quality. Let's take a closer look at some of the key benefits they offer. Consistency. One of the main advantages of process and control specifications is that they promote consistency throughout the development process. By defining clear guidelines and procedures, they ensure that every step in the software development is performed systematically and according to plan. This helps maintain uniformity across different stages of development. Quality measures. Process and control specifications also incorporate quality measures, such as regular code reviews and comprehensive testing procedures. These quality checks help ensure that the software being developed is reliable, functional, and free from critical defects. Implementing these measures reduces the chances of errors slipping through the cracks. Risk management. Another significant benefit is risk management. The specifications help identify potential risks early in the project, allowing teams to plan and implement strategies to mitigate these risks. This proactive approach reduces the likelihood of costly setbacks or delays during the development process. Benefit of continuous improvement. The process and control specifications provide a framework for continuous improvement. As development progresses, teams can regularly assess their work, identify areas for enhancement, and apply improvements. This ongoing feedback loop ensures that the software and development processes keep getting better over time. In summary, by using process and control specifications, software development teams can achieve consistency, high quality, better risk management, and an ongoing cycle of continuous improvement. Now, Let's discuss some of the disadvantages of using process and control specifications in software engineering. While these specifications offer significant benefits, there are also a few drawbacks to be mindful of. Specification causes overhead. One of the key disadvantages is that the level of detail involved in process and control specifications can create unnecessary overhead. Writing out all the detailed steps, procedures, and rules can take up a considerable amount of time and resources, diverting focus from actual development tasks. Resistance to change. Another challenge is resistance to change. Teams may be hesitant to adapt to new specifications, especially if the existing process has been functioning well. This resistance can slow down the adoption of updated procedures or the introduction of new control mechanisms, affecting the overall efficiency. Mismatch with project needs. Mismatch with project needs is another potential drawback. Not every project requires the same level of process specification. Some projects might have unique requirements that don't align with the general specifications, leading to inefficiency or unnecessary complexity in the process. Resource-intensive. Finally, process and control specifications can be resource-intensive. They demand significant documentation, which can be both time-consuming and require a lot of effort from the development team. This documentation process can divert attention away from core development tasks and add extra burden to the team. In conclusion, while process and control specifications offer structure and benefits, they can also lead to challenges related to overhead, resistance to change, mismatched project needs, and resource intensiveness. These factors should be carefully considered when deciding how to implement specifications in a project. To conclude, process and control specifications are integral in software engineering. They define the structured flow of the development process and set the necessary requirements for the software. By adopting these methods, organizations can streamline development, reduce risks, and ensure high-quality outcomes. Whether you're focused on managing resources,